afternoon. Welcome to Matt Zay's Mythbusters special. Before we begin today, I would like to introduce some of my crew members. This is Dan Gillespie. This is Shane Ford. And this is Brett Warner, our cameraman. In today's episode, we're going to learn about the boiling of water. So today, what are we working with today? Well, today we're working with the science of heat, and we are going to find out if warm water or cold water boils faster.
While we're at it, why don't we figure out which one freezes faster?
Well, it's obvious that the warm water will heat faster than the cold water. It's already hotter.
True, but some people believe that cold water will boil faster than warm water.
Are you sure? That doesn't really make sense. Are you sure those people are right?
There's only one way to find out.
Okay, so what do we need for this myth?
Well, for this myth, we need a stove, 2 pots of equal size, a measuring cup, a thermometer, and a fridge and a freezer.
Oh man, why do we need to have 2 of the same size pots and the same water level? Does it necessarily matter?
Actually, it does. The size of the pots and level of the water will determine how much heat will be produced. If we fill up both pots halfway, and one of them is bigger than the other one, the bigger one will produce more heat than the smaller one because there is more water. But it will take longer because there is more water to heat up.
Well, what is the boiling point of water anyway?
That's simple. The boiling point of water is 100 degrees Celsius, but there are other variables. For example, the elevation and purity of the water. Salt water will heat up faster than pure water, but for this experiment, we're just going to focus on fresh
So
water.
Matt, should we try this experiment with other forms of water?
No, for now we'll just stick with fresh water.
Alright then, here are all the items we need. Let's start this experiment.
We're going to begin the experiment by filling up this measuring cup with 2 cups of hot water straight from the tap. Now that we have our...
Should probably get down and measure it.
Yeah, that's a great...
Get down at eye level and make sure it's the right.
Gee, thanks, Brad. Now we're going to take our thermometer and measure the starting point of the water. And there it is, 43 degrees Celsius. Now we're going to take our 2 cups of water and put them in our pot. And now we're going to turn on the flame. Brad, how do I turn this on?
The water is now about to reach its boiling point.
The water is at 91.6 degrees.
It's been 4 minutes and 10 seconds. The water's coming up to the finish.
Shane, stop. The water just reached 100 degrees Celsius.
At 5 minutes and 1 second.
While we're waiting for all our instruments to cool off and the stove to cool off, we're going to fill up an ice cube tray with half warm water and half cold water and see which side freezes faster. Here's some nice steaming hot water. And here's cold water. Now we're going to measure the temperature of each. The temperature of the cold water is about 16 degrees Celsius. And the temperature of the warm water is 38 degrees Celsius. So we know which side is which. We label it with a W for warm and a C for cold. Now we're going to go ahead and put this in the freezer. And we just started our stopwatch. Now we're going to try the boiling experiment with cold water. Perfect. Now we're going to take the temperature of the cold water. The temperature of this cold water is 25 degrees Celsius. While we're waiting for this water to heat up a little more, we're going to check the status of our ice cubes. Our warm water has gone up to 23 degrees. Down.
Means back.
And our cold water has gone down to 12 degrees.
Matt, what is the freezing point of water anyways?
0 degrees Celsius. So the temperature just reached 97 degrees. Shane, what's our time?
We're at 6:04, which means the hot water definitely heated up faster than the cold water. We're just going to see how long.
98, 99, 100. Stop it, Shane.
6 minutes and 16 seconds. So Matt, what does this mean for our project?
Well, since the hot water did boil over a minute faster than the cold water, the myth is busted. Hot water does boil faster than cold water.
Sweet.
Now we're going to go check out on our ice cubes.
They're not even close to freezing.
Our warm water is down to 8 degrees. And our cold water is down to 6 degrees. Now we're going to go check on our ice cubes again.
Alright, 21 minutes and 24 seconds have passed since we put the ice cubes in the freezer.
Although our water isn't completely frozen, the cold water has reached 0 degrees, while the warm water is still at 2.4 degrees. Therefore, the cold water reached its freezing point faster than the warm water.
At what time was that at, Shane?
It was 21 minutes and 34 seconds. So the heating myth was busted, and the freezing myth ended up exactly the way we expected. What do you think we should do next?
Well, that's all the time we have now for this episode of Matt Today's Mythbusters special. Thanks for watching.
You may be wondering about the science behind all of this. It can be explained by a simple equation. That equation is Q equals mc delta T. In the equation, Q is heat, m is the mass, C is a specific heat, and delta T is a change in temperature. For example, in the hot water boiling experiment, the mass was 2 cups of water, the specific heat was 4.18, and the change in temperature, delta T, is 57 degrees Celsius. You multiply these things together and you get the heat, which is 476.5 joules. You can do the same thing with cold water by plugging in the same numbers, but instead of the change in temperature being 57 degrees, it's actually 75. Thanks for watching, and that's all for Stuff on Site segment.
Good afternoon. Welcome to Mythbusters. Good evening. Welcome to today's Mythbusters special.
Man, I do this correctly.
Actually, it does. The size of the pots and level of the water will determine how much heat will be produced. If we fill up both pots halfway, and one of them is bigger than the other one, the bigger one will produce more heat than the smaller one, because there's more. Wow, your fingers covered stuff now. Okay, yeah, that's fine.